Next topic we'll study about the nodal analysis, or another name of nodal analysis we can write it down as Kirchhoff current law. Remember I told you Kirchhoff is a scientist name, and on the basis of his name he gave two law. One law is based on KVL voltage and another law is based on KCL, Kirchhoff's current law. Okay, so what does this Kirchhoff current law states? That is sum of incoming current is equal to the sum of outgoing current, right? Like suppose I'm giving you an example. This is your room, okay? And like four peoples are entering in your room, okay? So how many people will leave the room? Four people only, right? One, three, four. So similar with the wire, if 4 ampere of current is flowing, okay, and the wire is split it suppose into two different parts. So 4 ampere will leave it. Now suppose from the above side 1 ampere will leave and from the below side 3 ampere will leave. Correct? So this is basically a node where the wire splits. The current which is entering into the node, that current is denoted by the incoming current, and the current which is leaving the node, that current is denoted by the outgoing current. Okay, clear? Now see, when of your friend is entering to you, then you will feel happy, right? Incoming current is always denoted by positive, and when they leave you, then you feel sad. That means outgoing current is denoted by the sum, by the sign negative. Correct? It can be vice versa, but make it a standard key. Always you need to take incoming as positive and outgoing as negative. Clear? Now suppose we'll have different wires with the same node connecting. Okay, this one can be I1, this one can be I2, can be I3, this can be I4. Now I1 is entering, right? I1 is entering, so that would be plus I1. I2 is also entering the node, that would be plus I2. I3 and I4 are the outgoing, so we can write it down minus I3 and minus I4 is equal to 0, right? So can we say that I1 plus I2 is equal to I3 plus I4? Hmm? Can we say that? So from this we'll get incoming current. These are the two incoming currents. So that would be sum of incoming current would be equal to these are the two outgoing current. We can say that sum of outgoing current, right? So we can denote it like sum of incoming current is equal to the sum of outgoing current, right? And from this expression we'll get a expression that is algebraic sum of all current entering in a node is equal to 0, right? Because it means that node is not taking a current. Whatever your current, you are giving the current to a node, that will be released, right? So it's algebraic sum. Some of the currents are positive and some of the currents are negative. That's why it is denoted by algebraic sum. Okay, so we can write it down like this also. Algebraic means the summation symbol. Algebraic current is equal to. Now this thing we'll need to use in the numerical when we'll do the Kirchhoff's current law. Okay.